In this lesson, we will focus on finding the derivative of logarithmic functions, but first let's start with finding the derivative of natural log functions. So for our first question, what is the derivative of the natural log of x? Before we start this, there's a formula that you need to know when finding the derivatives of natural logs. So the formula that you need to know is if I asked you to find the derivative of ln of u, the derivative is going to be u prime over u. So this is what you need to know to take the derivative of natural logs. So in this example here, u is equal to my argument, which is x, and u prime is the derivative of x, which would be 1. So according to the formula u prime over u, the derivative of the natural log of x would be 1 over x. Okay? Let's look at another one. What is the derivative of the natural log of x squared? And I'm actually going to show you two different ways that we could do this one. So the way I just showed you, we would identify what u is, and u is going to be equal to x squared. And then the derivative of u, which is u prime, would be 2x. So the derivative of the natural log of x squared is going to be u prime over u, so 2x over x squared. This could be rewritten as 2x over x times x, and I will just cancel. And the derivative of the natural log of x squared is 2 over x. Now I'm going to show you an alternate way that we could do this exact same question. So let's find the derivative of the natural log of x squared. With log laws, we could use the power law and bring the 2 to the front. So this would be differentiating 2 times the natural log of x. That would be equal to 2 times the derivative of the natural log of x, and this is something that you're just going to have memorized. The natural log of x, which is what we showed up here, was 1 over x. So the derivative of ln of x squared is going to be 2 over x. So for a couple of examples, I'll show both of these methods, and then you could decide how you're going to take the derivative. Okay, example 3. Differentiate with respect to x the natural log of x cubed. So again, according to the formula, it's going to be u prime over u. So u prime would be 3x squared over u, which would be x cubed, and then this would reduce to 3 over x. So the derivative of the natural log of x cubed is going to be 3 over x. Or an alternate way that we could look at this question is if I want you to take the derivative of the natural log of x cubed, you could bring the 3 to the front. And then we would be taking the derivative of the natural log of x, which is 1 over x, and that would give us a derivative of 3 over x, which is what we got up here. Okay, 4. What is the derivative of the natural log of x plus 5? So again, let's identify what u is. U would be my argument, which is x plus 5. U prime is the derivative of x plus 5. So the derivative of x is 1, and the derivative of 5 would be plus 0, which I don't need to write. My formula, the derivative of a natural log is going to be u prime over u. So 1 over x plus 5. Try this one. So number 5. I want you to differentiate with respect to x the natural log of x squared plus 4. And the other one that I want you to try would be find the derivative of the natural log of 7x plus 5 minus x cubed. Okay, so for number 5, if you want to take the derivative of the natural log of x squared plus 4, so it's going to be u prime over u. So u prime will be 2x over u, x squared plus 4. And that would be your derivative. For this one over here, u prime is going to be 7 minus 3x squared all over u, which would be 7x plus 5 minus x cubed. All right, try number 7. So what is the derivative of the natural log of sine of x? So u would be the sine of x. U prime, the derivative of the sine of x is the cosine of x. So u prime over u would be the cos of x over the sine of x. Now, the cos of x over the sine of x is the cotan of x. Okay, let's look at number 8. Differentiate with respect to x the natural log of the 7th root of x. So let's rewrite this, and we'd be finding the derivative of the natural log of x to the 1/7. From here, we have our two options. One of our options is u prime over u. Now, u prime, finding the derivative of x to the 1/7, remember you'd bring your 1/7 to the front, x, and then you'd be subtracting 1. The easier way to probably do this question would be to bring your 1/7 in front and say, find the derivative of 1/7 of the natural log of x. Because again, you know that the derivative of the natural log of x is 1/x. So it's going to be 1/7 times 1/x, which will give us a derivative of 1/7x. Okay, you would get the same answer if you did u prime over u. It would just be it'd be more work for that. Okay, let's look at the last example, which is example number 9. So differentiate with respect to x the 3rd root of the natural log of x. So let's rewrite this, and we're looking for the derivative of the natural log of x to the 1/3. Okay, we need to be careful with this question. The difference between 8 and 9 is the argument was raised to the power of 1/7, where this question, it's the natural log is raised to the power of 1/3. So what we'd actually be doing is this would be a chain rule question, okay? Now, remember when we're applying the chain rule, so just sort of as a side note for the chain rule, when you're differentiating f of g of x, and you're taking the derivative of that using the chain rule, what it's going to be, it's the derivative of the outer function, and you keep the inner function the same. multiplied by the derivative of the inner function, which would be g of x. Okay, so for this question here, we're going to do the chain rule. So the derivative of the outer function, we're going to bring that 1/3 to the front, and then we're going to have the natural log of x, and we're going to subtract 1, which is the same thing as subtracting 3/3. So that would be minus 2/3. And then from here, you're going to take the derivative of the inner function. Our inner function would be g of x, and that's the natural log of x. So what's the derivative of the natural log of x? Derivative of the natural log of x is 1/x. Now we'll clean this up. So in my numerator, actually, let's look at the denominator. I've got 3 and x, so that will be 3x. And I'm going to bring the natural log of x to the -2/3. I'm going to reciprocate it, bring that down to the denominator, so I could change that to a +2/3. So that would become the natural log of x to the 2/3. And then I have a 1 in my numerator. And then from here, I could further clean this up by just rewriting this natural log of x to the 2/3 as a radical. So that would be 1/3x, and it would be the 3rd root of the natural log of x squared. Okay, let's differentiate, which we've already done the natural log of x, but I'm going to show you sort of a proof by implicit differentiation. So let's prove the derivative of the natural log of x by doing implicit differentiation. Okay, so let's show this proof by implicit differentiation. So the function is the natural log of x. Now we, in the previous examples, we know that the derivative of the natural log of x is 1/x. And how we did that is I said that the derivative of a natural log is going to be u prime over u. So in this example, u prime, the derivative of x is 1, and u is my argument, which is x. So we know that the derivative of the natural log of x is going to be 1/x. So let's just show this, that we're going to achieve 1/x by doing implicit differentiation. Okay, so what are we taking the derivative of? Our function is the natural log of x. Now, we know that a natural log is a log with base e. So I'm just going to rewrite this function as log base e to the x. What I'm going to do is I'm going to get out of logarithmic function and I'm going to go into exponential function. So to get out of logarithmic function and to go into exponential function, I would have e to the power of y is equal to my argument, which is x. So from here, what we're going to do is we're going to take the derivative of this function, which is the same thing as the natural log of x. But how we're going to differentiate this is we're going to differentiate both sides of the equation with respect to x. So we're going to differentiate implicitly because I've got my y up here. So let's take the derivative of both sides with respect to x. So we know that the derivative of an exponential function when we have base e, so the derivative of e to the y is e to the y. And then I need to take the derivative of y. The derivative of y is 1 times y prime. That's equal to the derivative of x is 1. I'm taking the derivative, so I want to isolate y prime. So y prime is equal to 1/e to the y. So you might say, okay, the derivative we know of the natural log of x is 1/x. I have over here 1/e to the y. How am I going to get 1/x from this? Well, before we took the derivative, we showed up here that e to the y is equal to x. So e to the y is equal to x. So therefore, the derivative of the natural log of x is 1/x. Okay, let's look at some other examples here. So differentiate with respect to x the natural log of 8x. I'm going to show you sort of two different ways that we could look at this question. So u is my argument, which is 8x. U prime is the derivative of 8x is 8. And then from here, the derivative would be u prime over u. So 8 over 8x, which is 1 over x. One thing that I want to show you, which you're going to see in your homework for a couple of questions, and I'll point out which questions they are, we could also break this up. So we could use our log laws to separate this argument. And what I mean by that is the natural log of 8x, that's the same thing as y is equal to the natural log of 8 plus the natural log of x. Because you could pull these two natural logs together using the product law by multiplying 8 times x to give you 8x. So what I've done is I've just separated the arguments into two separate natural logs using the product law. Okay, from here, if I want to take the derivative of this, I could differentiate ln of 8 plus the ln of x. So y prime is equal to. Now, I know that the derivative of the natural log of x is 1 over x, or u prime over u. And then the derivative of the derivative of the natural log of 8. So if I, again, show u prime over u prime, the derivative of 8 is 0, and over u, which would be 8. So this will give me 0 plus 1 over x. So the derivative is equal to 1 over x. I'm going to show this example that's going to be more complex over here, where we're actually not going to do the quotient law. We're going to break this up into two different natural logs, and it'll be much easier for this question. Because you might say, like, why would we break it up when it was so much easier to do this? This question, it'll be easier to break this up, which I'll show you. Okay, differentiate or find the derivative of the natural log of cos of x. So y prime is u prime over u. U is equal to the cosine of x. The derivative of the cosine of x is negative sine of x. So y prime is u prime, which is negative sine of x, over u, which is cos of x. This is equal to the negative tan of x. All right, let's look at a couple more complex examples. So differentiate this function here. Now what you need to see is it doesn't matter what this inner function is. This is going to be a chain rule question. So we're going to take the 4 to the front, write the original function stays the same, the inside function stays the same, subtract 1, and then we're going to take the derivative of the inner function. So y prime is equal to, so according to the chain rule, it would be 4 3x squared plus the natural log of x, subtract 1, and we're going to get 3, multiplied by the derivative of the inner function. So the derivative of 3x squared is 6x plus the derivative of the natural log of x is 1 over x. Now from here, I'm going to show you how we could further clean this up. I'm going to write this bracket. I'm going to bring my x to the numerator and write it as x to the power of negative 1. So this would give me y prime is equal to 4 3x squared plus ln of x cubed times 6x plus x to the negative 1. The reason why I'm doing that is because what I want to show you is from this factor here, or from this bracket, we could actually factor out, because I've got x that's common, remember we could always factor out the term with the lowest power. So from this bracket, I could factor out an x to the negative 1. What that would give me is I'm going to bring down this 4. Then I'm going to write the x to the negative 1 that I factored out. This bracket, nothing's changing. And this bracket, if I factor out an x to the negative 1, so what I will have is I will have, remember that according to your exponent laws, it's going to be 1 minus negative 1. So that's going to give you x squared. This will cancel and it will leave me with a 1. This is the answer, but I could rewrite this by reciprocating the x to make it positive. So to clean that up just one more time, it would be 4 over x. And that would be the derivative of the original function. Okay, this question here. Taking the natural log, and here's my argument. It's going to be quite complex if you try to do u prime over u, because we would have u prime is going to be quotient law. So we're going to have a complex fraction. We'd have a fraction over a fraction. So what I want you to see is that I could use my log laws to separate this. So let's rewrite this as y is equal to the natural log of x minus the natural log of the square root of x squared plus 1. Because again, I could join these two logs together by using the quotient law, right? This argument would go in the numerator, this argument would go in the denominator. The reason why I want to separate this is because I can easily take the derivative of the natural log of x, and this one, when I rewrite it, will actually be quite easy as well to take the derivative of. So let's rewrite this natural log. So we'll have y is equal to the natural log of x minus the natural log of x squared plus 1 to the 1/2. And then we're going to rewrite that again, because I will bring that 1/2 to the front. So I would get y is equal to the natural log of x minus 1/2 times the natural log of x squared plus 1. All right, now let's take the derivative of this. So y prime is equal to, I'm going to differentiate the natural log of x, and I know that is 1 over x minus 1/2, and then I'm going to differentiate the natural log of x squared minus 1 by using the formula of u prime over u. So u prime is 2x over u, which is x squared plus 1. Okay, the 2 over the 2 will cancel, and I'll have y prime is equal to 1 over x minus x over x squared plus 1. From here, let's join these two fractions by getting common denominators. So how I'm going to do that is I have an x here. I'm going to put an x here and an x here. I have an x squared plus 1. So I'm going to put an x squared plus 1 and x squared plus 1. So y prime is equal to, so getting common denominators, it would be x and then x squared plus 1. Each of my terms has that now, so that would be my denominator. And then my numerator is going to be x squared plus 1 minus x squared. So x squared minus x squared will cancel, and I will just be left with 1. Once I finish these last two examples, I'm going to get you to pause and do one question in your homework. But one thing I just want to quickly point out is this question right here. I want you to use this strategy of breaking it up into two natural logs when you do homework question 1K. So just to quickly show you, 1K, you do not want to do u prime over u because we're going to have a fraction over a fraction. So split this up. I could take that 1/2 and I could put it on the numerator, take that 1/2, put it on the denominator, and then split it up by, it would be the natural log of x to the 1/2 minus the natural log of x to the, or 2x plus 3 to the 1/2, and then take the derivative of this function and take the derivative of this. Okay? All right, let's look at these last two examples, which is going to be taking the derivative of the natural log of the absolute value of a function. So the first thing that I want to show you when we have absolute value, remember that in order to get rid of this bracket, we have when x is greater than 0 and when x is less than 0, right? So we have if x is greater than 0, if x is less than 0. So what happens is if my equation is y, or sorry, the equation is y is equal to the natural log of the absolute value of x. If x is greater than 0, then what that would be, that would just be y is equal to the natural log of x if x is greater than 0. Okay? And we know that if I was to take the derivative of the natural log of x, I would get y is equal to 1 over x. And that would be the derivative of the natural, that would be the derivative of the natural log of the absolute value of x if x is greater than 0. If x is less than 0, so if we have y is equal to the natural log of the absolute value of x, remember that if x is less than 0 and its absolute value, in order to get rid of the absolute value bracket, we put a negative in front of the function. So that would be y is equal to the absolute value of negative x. If I said, okay, well, what's the derivative of negative x? Y prime, it's going to be equal to u prime over u. That's equal to u prime, the derivative of negative 1x is going to be negative 1, all over negative x. The two negatives will cancel, which will give me 1 over x. So what I want you to see is that if I give you the function of y is equal to the natural log of the absolute value of x, it doesn't matter in this example what x is, whether x was greater than 0 or whether x was less than 0, the derivative is 1 over x. Okay? Now, let's look at this one. Y is equal to the natural log of the absolute value of 3x squared minus 5. For this function here, the absolute value actually doesn't matter, and we would take the positive case of this anyways, because remember that with logs or natural logs, your argument can't be negative. So what that would mean is this function is actually the natural log of 3x squared minus 5, because we can't have a negative argument, so the negative case doesn't apply. If I said, what's the derivative of this? The derivative of this is going to be u prime over u, which is going to be 6x over 3x squared minus 5. Okay? Again, I'll show you where this is in the homework. So before you do the second part of the video, which is going to be the derivative of logarithmic functions, I want you to do question 1 on page 383. So I have the work solutions for you. So here are all of the work solutions for question 1. And then the one we just did, again, there's one example with an absolute value. And again, the argument can't be negative, so we're just going to be taking the positive case anyways. And this would be the same thing as y is equal to the natural log of 2x plus 1. I'm just able to get rid of the absolute value symbol. And then from here, the derivative of the natural log of 2x plus 1, I'm going to use the formula of u prime over u. And then you'd be done your question.